Good afternoon, everyone. Excited to be here and share with you our project. This project was a result of a big hackathon called Somos NLP that was organized by Maria. So thanks, Maria. Also was a collaboration from the Universitat of Barcelona, Fundación Universitaria Los Libertadores in Colombia, and the Instituto Técnico of Castilla y León in Burgos, Spain. So in this dataset, we were working with Nicolai, Santiago, Pineda, and me, Edison. So the first thing that I want to start is with the motivation for this project. So first, what is accessibility? And in the aeronautical field, what is accessibility for the data? So the goal of accessibility is basically that everyone have the opportunity to access for some information in the same conditions. But in the real world, that is not happening because RAC, I need to say first what is RAC, it's not RAC, it's aeronautical Colombian regulations. And these documents are quite hard because they have some specific vocabulary that are for aeronautical regulations. And also, if, for example, in the field of aerospatial field, if you need to change whatever part of an aircraft, you need to follow some process. For everything, you need to follow a process. And with that, many of that companies and also the government that create these rules need to use some people to search that information, that specific information. So with that, people as us, mortals, we don't have accessibility for us, for that information. So in this paper, we wanted to improve that. So the general objective was to use large language models to make Colombian aeronautical regulation more accessible and understandable for aviation professionals and the general public. With that, we have three specific objectives. The first one was to develop a comprehensive data set from initial RAC documents for LLM training. The second was to collaborate with the industry and academic experts for dataset annotation and refinement and the refinement. The third one was to train LLMs models with the curated dataset and evaluate LLM's performance in simplifying RAC content. With this, I need to present our rock stars. They are Danny Stevens, Ale Mauricio, Sergio Nicolas, and Felipe Ivan. They was doing the hard task to, I'm going to share in the next slides, but they was doing the hard task to annotate the dataset. So with this, we was following a methodology that was split in 4 parts to be more simple. The first one was the data generation. The second one was the labeling. The third one was the model fine-tuning. And the last one was the validation and evaluation. So to go more in deep in the dataset generator, as you can observe in this part, we have the RAC datasets PDFs that are many PDFs, many of them. And we was, the intention of this pipeline was to generate a synthetic dataset. How we was doing that? So we was taking one PDF, for example, we was passing for this loop, and in this loop, we was extracting. First, we was using some pre-processing techniques, and then we was reading the content of the page. But here we was using not one page, we was using 2 pages to overlap the information, to don't lose the information, because some of the information was, for example, in the below part of the page, and in the next page, continue the information. So that is why we are overlapping the information. After that, we was using some open source models like Mistral and Llama, and also we was using GPT model to generate the samples. But why open source models? Because in this field, we have some information that are complicated to share with others. So that is why we was using bots kind of models. So when we was generating the models, the sample, sorry, the sample was composed for 4 things. First one was the question. The second was the answer. The third one was the page of the information. And the last one was the RAC number. Okay, with that, we was generating the samples until we don't have more PDFs or we don't have more pages. At the end, we have the first version of our RAC dataset, but that is only the first step, because then we have another pipeline to take that RAC dataset and mount the RAC dataset into the Hugging space using an Argila framework. Argila gave us the opportunity to put the dataset in a friendly way for people that are not technological experts. And with that, they can manipulate the data, the samples. And for example, they can convert or fix the information for some question or some answer. And also they have the opportunity to run the quality of each of the samples from 1 to 5. With that information, for example, we discard the sample that was with quality less than 3, and we store samples with quality with a quality more than 4. And at the end, we have a clean data set. With that, we fine-tuned the models, and you can observe here, we have a version of the fine-tuned models. We trained it with GMA 1.1 2B instruction. And also we was using techniques as PEF, Colora, slot, and flash attention. With that, we can reduce the use of big GPUs. We was starting with a 800 and we finished training with a RTX 1390. Later, we have some results for the 8 versions. We have a good loss, but the most important thing here was in the moment that we asked us how we can evaluate this model. That is very important because many people exist many methods, but for our case, we think that the best way was to create a methodology in where we was generating, for example, for the RAC one, we generate 100 tests, and for that test, we have the ground truth. So the experts was measuring the RAC. For example, for the RAC one, we have a mean of 6.12 and a median of 7. So with that, we can measure with humans. And we evidence for RAC 3 that we get the worst results. And with that, later we were researching why, and was because we don't use each RAC have a different content. Okay, so with that, at the end, sorry for that, we generate a big data set of 50,000 samples. And we have an open source model in where you can use also. And acknowledgement for these people. So if you have any question, please don't hesitate to tell me.
Hi, thank you for the talk. Very nice. So I'm interested in the part of discarding the samples.
Yeah.
So
here.
Yes, there. So do you have any intuitions on the reasons for discarding, and was more than one person making the decision, like where?
Yeah, was doing for 4 people, was doing the decision, and the methodology was we need to search the information in the document, how is the information there, and with that we can say if the quality of the sample. For example, when you are extracting the information, you generate the question and also the answer. So they take the answer and they go for the document in specific with the page and the number. That is why we have here in the samples, we have the pages.
Mm-hmm.
So that was our methodology to search the information for the annotators.
Okay, so they had to find the answer, and it had to be the correct one in that page and with that.
That was very challenging, yes.
Okay, and do you have an idea of the agreement of the annotators there? Like...
Yeah, because we was working on that. I mean, we put like the methodology and we shared with all of them, mm-hmm. and we was trying to check in all the time that they was doing in the good way.
Okay, and last question. So, what was the percentage of discarded?
What was the what? Sorry.
The amount of discarded question, like the percentage, or
was 35% of the data was discharged.
Okay,
and the other was improved. So yeah.
Yeah, that's cool. Thanks.
You're welcome.